Hey everyone, welcome back to the Advanced Network series with Network Security Integration. I am Harika and today we are diving into Network Security Integration NSI, focusing specifically on in-band mode. If you have ever set up third-party firewalls in the Google Cloud environments like Checkpoint Firewall or Fortinet or Palo Alto, you know that balancing deep traffic inspection with clean routing is a classic challenge. Standard setups often require heavy source NAT configuration, which masks your original IP addresses, multi-NIC firewall deployments, or intricate route tables that are tough to maintain at scale. That's where Google Cloud's network security integration comes in. It offers a much cleaner approach, letting us intercept packets transparently using native cloud firewall policies in a bump in a wire mode. In this video, we are going to look at how it works and how to deploy NSI. I will now turn it over to Gus Coronel from Checkpoint. Gus will walk us through inserting a checkpoint firewall directly into your traffic path for real-time deep packet inspection between internal VMs, delivering a seamless microsegmentation without any route changes.
Thank you, Harika. It will be my pleasure to show a demo of CloudGuard Security Gateways leveraging the new Network Security Integration Inline Mode, also known as NSI. Of all the capabilities provided by NSI, microsegmentation is actually my favorite. Microsegmentation is not normally available through the usual routing implementations, but it is something that I consider critical in many environments. So let's talk about my demo environment. It is very simple. We have a pre-existing VPC, and that VPC has 3 virtual machines. 2 of the VMs are in the exact same subnet, and that is where I will be focusing. We want to show that NSI allows you to do full layer 7 deep packet inspection, even when the VMs are right next to each other. In this specific environment, we have started with a single VPC, but we're going to add the NSI provider service, which can be done very easily via Terraform. Once we run the Terraform template, the result is going to be pretty much what you see on the screen. There's quite a bit of new plumbing underneath. We now have a producer VPC, and we have added the checkpoint gateways to it. And just like that, we're ready to go. Now, for this demo, I'm not going to spend a lot of time talking about what happens behind the curtains. I'm going to ignore the endpoints, the associations, the deployment groups. They're all there because Terraform took care of those relationships for us. But instead, I'm going to concentrate on using this new capability after it has been deployed. Case in point, let's type firewall in the GCP portal search bar. This brings up the firewall page, and at the very top, you're going to see the VPC firewall rules. Those are not the ones tied to the NSI inline capability. We have to scroll down, and at the bottom, you're going to find the network firewall policies. The network firewall policies are the ones that actually dictate what gets intercepted, what gets put into the tunnel, and delivered to the firewalls for inspection. And here we see that we have our demo VPC associated with this policy. We can have multiple VPCs associated with the policy, but in this case, just the demo VPC has been associated. When we click on that firewall policy, we're going to see the actual rules inside. These are very basic for the purposes of the demo. We have 2 rules, one for ingress, one for egress. The rules encompass pretty much all the traffic entering or leaving any of the VMs we have in this VPC. These are the packets that will be intercepted and inspected. The action column at the very end does not show a simple accept or drop, but that we are actually redirecting to our inspection profile. In this particular demo, I have an Ubuntu Virtual Machine 1 and an Ubuntu Virtual Machine 3, both located inside of the same subnet. The blue terminal sessions on the top will be associated with those VMs, and we're simply going to connect from one to the other. If the firewall policy rule that redirects is disabled or showing accept as the action, there will be no redirection and no interception. Everything between one VM and another is going to flow directly. But If we enable the rule or select to enforce or profile as our action, then we're going to see that the packets get intercepted as they leave our source VM. They will be encapsulated inside of a Geneve tunnel and delivered to a checkpoint CloudGuard firewall where the traffic will get inspected. If approved, the packets will be sent back through the same tunneling mechanism and drop exactly where they were picked off so that they can finish the journey to their original destination. Now let's take a look at those packets as they move through the new environment. Down here with the black background and the green text, we have our firewalls. Only a 2-member firewall managed group in this demo, but the MIG can scale as large as it needs to be. Above it with the blue background and the yellow text, we have our Ubuntu VMs with VM1 and VM3. VM1 is the source on the left, VM3 will be our destination on the right. When we execute a ping, we can see that the send and reply packets are echoed on the Ubuntu terminals, but we also see them being captured in the firewalls. We can visually confirm that they have been redirected to the firewall. If we take a look at the output, we can see that it's encapsulated traffic. We can see the Geneve UDP protocol. We can see that each packet has 2 sources and 2 destinations in the header. At the very top, we see the 10.0 IPs for the tunnel source and destination. And inside the encapsulation headers, we have the actual 10.12 addresses from the Ubuntu VMs themselves. So whenever we want to capture the traffic at the interfaces of the firewall using TCP dump, we have to remember to capture on UDP port 6081, which is the Geneve protocol, because we will not be able to capture the correct traffic otherwise. Once we are capturing the UDP encapsulated packets, we can then look for actual original IPs inside of those headers, which will be visible. So now let's take a look at the firewall management console. We want to make sure that the logs show the packets in here. If we look at the logs, we can see we actually do see the pings. It is very straightforward. If we change our security policy to drop the packets instead of allowing them, and we repeat the traffic, we will see that it's no longer reaching its destination. If we go back to the firewall logs and refresh them, we can verify that the packets are indeed being dropped. Again, I want to stress that we are redirecting to a layer 7 deep inspection security gateway. We can use NSI microsegmentation to do way more than just access control. We can recognize and prevent bot traffic, malware hiding inside of a payload, attack evasions, injections, in summary, way more than just access control. As a final reminder, I would like to stress that microsegmentation is just one of the many added capabilities provided by the NSI Network Security Integration Architecture, allowing standard east-west as well as north-south based security, TLS inspection, and much more, leveraging an architecture that eliminates the need to use routing to funnel packets into a security gateway. I recommend that you check it out. Thank you very, very much.
Thank you, Gus. As you saw, NSI gives you that robust bump in the wire security protection while keeping your cloud routing completely clean. I have left the link to the official documentation and the step-by-step code lab down in the description box below so you can try this deployment yourself. Thank you so much for watching.